Hi guys, today we're looking at the discriminant. Our learning intention for today is by the end of this lesson you will be able to state what the discriminant is, recognize if a quadratic equation has 0, equal, or 2 real roots using the discriminant, and solve for unknown coefficients in a quadratic equation using the discriminant. So your discriminant is the number in the square root of your quadratic formula. So our quadratic formula is what we use to solve for x minus b plus or minus the square root of b squared minus 4ac all over. That's all over 2a. So the discriminant value is the value that's under your square root. And we use our delta symbol to recognize the discriminant. The value of the discriminant can be used to determine whether a graph cuts, touches, or does not cut the x-axis. When your discriminant is greater than 0, a graph crosses the x-axis twice. We state we have real roots, 2 real roots that are different values. If b squared minus 4ac is equal to 0, our graph touches the x-axis. In this case, when we solve for our values of x, we would have equal roots. This means that when you solve for the value of x in your quadratic equation, you would get x equal to plus or minus a value. So x is equal to plus or minus 4, i.e. you have equal roots. This means that your function touches the x-axis. And if your discriminant value is less than 0, we have no real roots. This means that your function does not cross the x-axis. If the discriminant is positive, there are 2 real answers. If the discriminant is 0, there is 1 real answer. And if the discriminant is negative, there are no real roots or no real answers. You have what's called complex answers. Let's look at a question. We're asked to describe the roots for the following equation. X squared minus 8x minus 33 equals 0. To describe the roots, we must find the discriminant. The discriminant is equal to b squared minus 4ac, where a is the value in front of the x squared coefficient, b is the value in front of the x, and c is the value that is on its own. This gives us a equals 1. b equals minus 8, and c is equal to minus 33. Substituting these values into our discriminant formula gives us minus 8 squared minus 4 times 1 times minus 33. Putting these values in our calculator and we get 196. 196 is positive or greater than 0, and therefore your equation has 2 real roots. That means that this function will cross the x-axis at 2 points. Okay, let's look at another example. Tell me the discriminant and find the roots of the and the types of roots that we have. So we have x squared plus 6x plus 9 equals 0. Our discriminant is equal to b squared minus 4ac. In this case, a is equal to 1, b is equal to 6, and c is equal to 9. Substituting these values into our discriminant gives us 6 squared minus 4 times 1 times 9, which is equal to 0. Therefore, our equation has 2 equal roots. Let's try another. Find the discriminant and the type of roots. Our function is x squared plus 3x plus 5 equals 0. To describe our roots, we must find the discriminant, b squared minus 4ac, where a is equal to 1 in this case, b is equal to 3, and c is equal to 5. Substituting these values into our equation gives us 3 squared minus 4 times 1 times 5. This is equal to minus 11. Minus 11 is less than 0, and therefore this equation has no real roots, i.e. this function does not cross the x-axis. Here's your x-axis, and here's your very wobbly y-axis. Let's try one more. This question is slightly different, and it is a common question that we use the discriminant for. Find the value of k if x squared plus 6x plus k has 2 equal roots. So here we want to find our unknown coefficient in our quadratic equation. And to do this, they are telling you information about your discriminant. Equal roots state that b squared minus 4ac is equal to 0, where a is equal to 1, b is equal to 6, and c is equal to k. Substituting these values into our discriminant gives us 6 squared minus 4 times 1 times k equals 0. And from here we solve for k. K is equal to 9. Okay, so when you're trying to find an unknown coefficient in your quadratics, find your discriminant and put it equal to 0 if you have 2 equal roots, and solve for your unknown value. Please pause and take down this example.